Yeah, hello friends. Now we discuss about 8086 interrupts. I think you know what you mean by interrupt. It is a desired or undesired obstacle to the CPU or to the main program for its needness. Either it may be the desired interrupt or it may be the undesired one. And for 8086, there are possibly three sources for the interrupt. One, because of external signals due to the hardware devices, we call it as hardware interrupts. And second, due to the internal programs, as due to some programming, those we call it as software interrupts. And some other due to the errors which are going to occur while executing a program like a divide by zero. So these are going to be the possible sources for interrupt. One is hardware, for example, NMI. The second one is software, which are INT, and third one is errors like divide by zero. Let me see basic terminology of interrupt before going to discuss about this. Interrupt pins. So for handling interrupts, 8086 contains some pins like NMI, INTR, INTA bar to handle the interrupts. NMI is going to be the non-maskable interrupt request. INTR is going to be the maskable interrupt request, and INTA bar is going to be the response or acknowledgement for the interrupt INTR. And coming to ISR nothing but interrupt service routine, also called it as interrupt handler, which is going to be executed upon identifying the valid interrupt by the CPU. And interrupt priority. So the interrupts may be of having various concerns and various priorities. Some are having highest and some are having lowest priority. And when some interrupt occurs at a time, then we need to execute the interrupt having highest priority. An interrupt vector table. The interrupt vector table, which is available in the memory, that contains the address of ISR, and then interrupt masking. So all interrupts may not to be serviced. Some are going to be maskable and some are going to be non-maskable. Which are maskable, calling it as interrupt masking. Maskable means can't be executed, can't be needed to execute. And non-maskable interrupt, which should not be ignored when it occurs. It's all called as non-maskable interrupt. And let me see how interrupt is going to be processed in 8086 when interrupt occurs. When interrupt is requested, then the content of flag register, especially the IF flag and TF flag, are to be preserved. Hence, those are going to push it onto the stack and disables the INTR interrupt by clearing the IF, so that no other interrupt occurs while servicing the earlier interrupt, and reset the TF to disable the single step or trap interrupt. This is an optional step. And main thing is we need to push the current address, otherwise the address of the next line to be preserved. So its CS value and its SIP value are going to be pushed onto the stack. Once they are pushed onto the stack, the ISR, interrupt service routine, its address from the interrupt vector table can be popped into the P, PCR IP and CS, so that the CPU can execute the interrupt service routine. This diagram clearly explains how interrupt is going to be processed in 8086. So this is the main program in which it is running. At one point of time, interrupt occurred. Because of interrupt, it is going to push the flag, clear IF and TF, push CS and IP, and load CS and IP of ISR. Accordingly, it go to the interrupt service routine and gets address and go to execute all that interrupt service routine. Finally, because of IRET, interrupt from routine, interrupt from are written from the interrupt in it go backs and pop IP and CS which are pushed here, and so that it can continue the main program. Yeah. Now we'll see the interrupt vector table of 8086. There are totally about 256 interrupts that can be served by the 8086. So in hexadecimal, we call it as type 00 to type FF, totally 256. And for each vector, there will be of 4 bytes allotted, 2 bytes for the CS and 2 bytes for the IP. You can observe for type 00 and 00000 and 00001 are allotted for preserving IP value, and 00002 00003 for preserving the CS. Similarly, for each and every interrupt, so 2 bytes for the IP and 2 bytes for CS are going to be allotted, and among them 5 important interrupts are type 00 to type 04, type 0 for divide 0, and type 1 for single step interrupt or trap interrupt, type 2 for NMI, type 3 for breakpoint or 1 byte interrupt execution for step-by-step execution, and type 4 for overflow interrupt. And from 0 to 4, these are the main interrupts that are available in 8086, and type 5 to type 31 are reserved for advanced microprocessors, and remaining from 32 to 56, so which are going to be useful for either software interrupts or for hardware interrupts. So totally 256 possible interrupts which may be of hardware and software can be served by this. And the mnemonic for this is int followed by n. N is a type. It starts from 00 up to ff. For example, when it is int21, and whenever this interrupt occurs, it executes interrupt of type 21h, and upon executing it, it is going to have iret. Upon observing iret, it comes back to the main program. If we see some of the uses of this software interrupt, for example, if we have int03, int03 is for breakpoint. So it's going to provide you breakpoint while debugging. So if you have breakpoint, you can easily observe the response of the program. And int02 is for non-maskable interrupt. This is to test the correctness, function correctness of various ISRs. Here, if you observe, various timing cycles you are given T1, T2, T3, T4. At T1, ALE is raised so that address is going to be separated, and at that and after that, if you are observing, the INTA bar is low from 8086 to 8259, means interrupt occurred, and 8086 is to provide acknowledgement, then only that interrupt can be serviced. So at this point again uh, INTA bar is again low, so that interrupt acknowledgement is reached to the 8259A. At that time, a type vector from 825559 or 74244 known by the CPU, and accordingly it gets the address of ISR. If it gets the ISR, it is going to service it. And in this way, 8086 is interfaced with a 8259 interrupt controller. So this interrupt controller first requests the 8086 with INTR. Upon seeing its validity, so it is going to raise its INTA bar to this, and accordingly 8086 gets the ISR address, ISR vector address. If it gets ISR vector address, it is going to execute it and come back to the main program. And these are the priorities that are given for the 8086 various interrupts, starting from divide by 0, intent in 0, which will be having highest priority, and single step a trap will be having the lowest priority. So these are all about the interrupts of 8086. Thank you.